This is section 6.2 notes. And so you may remember that in 6.1, we talked about how to use, here we go, how to use the vertex form of the equation for a parabola in order to graph the parabola pretty quickly and easily, okay? But that only works if it's in vertex form, okay? So let's talk about a little refresher. What was vertex form? Remember, vertex form is where you have maybe some number out in front, and then you have x either plus or minus some number, we'll call it h, right, squared, and then plus or minus another possible number we'll call k. And so remember, the a, the h, and the k, those are places where you could have numbers that somehow affect your graph. Okay, well, today is all about how do I draw a graph if it's not in vertex form? What if it doesn't have that parenthesis squared? Okay, so if a quadratic equation is not in vertex form, you should change it to vertex form by completing the square. Okay, so we are going to make it look like vertex form. And what that means is we're going to make it look like y equals some parenthesis squared. Now we may put some number out in front. We may put, there's my x, we may put some number added or subtracted inside, and we may put some number out at the end. So basically we have to decide what should the a, the h, and the k be. All right, and the easiest way to do this is you start by looking at just the x terms right here. So the easiest thing is knowing what to put in the parentheses. It's always going to be whatever that sign is right there. So I know it's going to be a minus. And then in order to get the number that goes in the parentheses, you always just take half of that number that's in front of the x. Since it's a 6, half of that would be 3. I mean, that's automatic. You don't even have to think about it. You put that number in there. Okay. The next part is kind of the part you actually have to think about. Now, this next part, I'm going to kind of show you where it comes from, but when you're actually doing these problems, you don't have to write all this out. So here's the thing. By writing it as this parenthesis squared, if this were multiplied out, right, if I did x minus 3 times x minus 3, right, I have to do FOIL. I would have x squared. Both the outer and the inner would be negative 3x, so it would turn into a negative 6x. And then the last number, the negative 3 times negative 3, would be a plus 9. So basically, by turning it into this parenthesis squared, I've taken what it was up here, right, and I've turned it into this x squared minus 6x plus 9. Well, notice x squared minus 6x, that's exactly what's here. That's not the problem. The problem is that last part, right? So it's supposed to be a plus 10, but by writing it this way, I've turned it into a plus 9. So I've adjusted the equation. Well, you can't just change the equation. You have to keep the same original equation. So here's the idea. If right now, really this ends in plus 9, what am I going to have to put at the end here that's going to turn that plus 9 back into a 10? Well, couldn't I just add 1? Right? Because if I add 1 to the 9, it would be a 10. So this is the vertex form. So I could say, oh, okay, this parabola is moved 3 to the right, 1 up. Since there's no number out in front, it's like an up 1 over 1. And there's my basic parabola. Okay, look at number 2. So like I said, you automatically set up your parenthesis squared. It's easy to know what fills in the parenthesis. Since this is a plus, I know this is a plus. I take half of my 8 number, which would be 4. Okay, now, I'm not going to write all the stuff out that I did above, because if I were to do the FOIL, I know that this first part is going to be the same. You don't even have to check it. I'm telling you it's going to be the same. The only part that would be different if this were multiplied out is that last number. Well, that last number is just the 4 squared, right? So if this is multiplied out, right now the last number is 16. But I don't want it to be a 16. I want it to be a 14. So what am I going to put at the end? That's going to turn that 16 into a 14. Well, wouldn't I just need to subtract 2? So that is my vertex form. So 4 to the left, 2 down. There's no number out in front, so I think of it as an up 1 over 1. Yes, I know this parabola goes off the side of my graph, but That's fine, doesn't matter. Okay, now look at example 3 and 4. Something to pay attention to. Notice on, yes, that's my dog. Notice on example 1, there was no number in front of the x squared. On example 2, there was no number in front of the x squared. When I get down here to example 3, I've got the negative in front, and then example 4, I've got that 3 in front. Okay, so that changes things a little bit. Because here's the rule, you can't complete the square if you have anything in front of your x squared. So that's why example 1 and 2, I just jumped in and started setting up my parentheses. I can't do that on 3 and 4. So what we're going to have to do is, again, this is going to seem a little strange at first, but what we're going to have to do is whatever's in front of the x squared, you have to factor out. So I'm going to have to factor that negative out, and this is going to be what's strange to you. We're not factoring this problem. I'm not trying to do trial and error, just trying to change the way it looks. I'm only going to factor the negative out of the x's. So if I take out a negative, I'm going to have x squared. If I take out the negative from the negative 4x, it's going to become a plus 4x. I'm not taking the negative out of the plus 1. I'm just going to leave that plus 1 at the end. Again, we don't normally do that, but we're not trying to factor this problem. We're just trying to change the way it looks so that we can easily complete the square. Okay, now I'm ready to set up my parentheses squared. So because I have that negative out in front, just keep the negative out in front. And now everything is the same. I'm going to fill this parenthesis in, x plus, take half of that 4 is 2. Okay, so here's the part we're thinking out. If this were squared out, that last number would be a 2 squared, so the last number would be a 4. Now here's something you have to be careful of. Because of this negative out in front, once you square this out, that negative is going to distribute to everything. So it's not just a 4, but it's really a negative 4, okay? But I don't want negative 4. I want plus 1. So what am I going to put at the end that would turn that negative 4 into a plus 1? Well, we're going to have to put plus 5. So there is my vertex form. So 2 to the left, 5 up. Yes, it goes off the top. That's okay. That's a negative out in front, and because there's not a number, it's an implied 1. So down 1, over 1. So that's how I know this parabola actually opens down. Okay, look at example 4. Again, you can't complete the square with that 3. So you're going to factor that 3 out, but we're only going to factor it out of the x terms. So I'm going to have x squared plus 2x. I'm just going to leave the plus 1 at the end. Okay, so now I'm ready to complete the square. Just leave the 3. So I would fill this in as an x plus half of 2 is 1. Okay, here comes the thinking part. If this is squared out, 1 squared is still 1, but all of that is being multiplied by 3. So really I have here a 3. I don't want 3. I want plus 1. So what am I going to have to put at the end to turn the 3 into just a 1? I'm going to have to subtract 2. So there is my vertex form. So 1 to the left, 2 down. The number out in front is 3, so I'm going to go up 3 and over 1. So this is going to be a little bit more narrow parabola. Something like that. Okay? So that's how we graph if it's not already in vertex form. So you'll notice on the homework, none of these are in vertex form. So you're going to have to complete the square on all of these before you can actually do the graphing. Okay, that's why you'll see on the homework here, there's like some space in here. See all that space? That's for you to complete the square so you can graph it. Okay, remember these are all no calculator.